Hey, I'm Ryan with Warner Discovers, and today I'm going to show you a multi-month process that I took with adding solar into the shed. Now, my current shed does not have any electricity running to it, so I was looking to run things like charging the batteries for my DeWalt and Ryobi tools, as well as just having outlets for running my saw or air compressor, anything that I've been lugging out of the shed to save me lots of time and convenience. One of the products I first got excited about was the Ubiquiti Solar Point, and I thought it was pretty neat. You can hook it up directly to the solar panels and it provides power remotely for you to run any PoE devices such as like a camera or anything that you would need sort of in a remote area. It seemed like a good product to try to integrate with the shed, so I started there, and let's see how the process goes. Now, if you're looking for any of the items I have throughout this video, all the product links are in the description, and I'll go over all of that right after I show you how the whole process went. I also broke the video up into different sections, so feel free to jump around. Just got the solar panels in and testing, and you can see I'm getting a reading around 24, so that's good for both of these. Now I have the panels wired in series, so I have the negative of the first panel connected to the positive of the second panel, and then just doing a reading here, and now I'm getting double the voltage. Starting out the solar project, I just want to show you what I have. We have the SunMax, which I did an unboxing for. I have 10 feet extension cables, which are probably a little longer than I needed. I have the Unify AP that's going to connect the SunMax to my home network wirelessly. Then I have this solar gland, which basically has the weatherproof solar connectors on the outside, which go right into the inside of the shed and go right into another pair of solar connectors. So I don't need to modify any of the wires and set up my own gland and all that. It just saves me a little extra effort. And then we have the mounts for the solar panels, and I have two of these. So these are going to go on the bottom of this, and I'll show you how those go together. And that includes these two bolts. One goes through the roof and one goes onto the panel. The only thing I'm missing is the batteries, and that will come later. Finally, when I do put these mounts on, I'm going to use some of this waterproof sealant with the screws, which I will use with my caulk gun. So first I'm going to take the mount and put it on the side here. You can see these two edges go on the outer side. You can choose which hole you want to go on the bottom. There's a bunch of them down here. I'm going to choose the second most inner one. And then we have two washers, and then a lock nut, a regular nut, and the bolt. First I'm going to take the bolt, put the washer on, then I go through the bottom here, and then I'm going to put the washer, then the lock nut, and then the nut. So now we have the bolt, the washer, the lock nut, and then the regular nut, and then I'm going to tighten that down when I have all four. I got all four of them on. I'm going to tighten it down with this 10mm. Just till it's good and tight. Panels are tightened up, and I'm just going to show you, these are the screws that come with the Renogy mounting brackets. They're self-drilling wood screws with this little plastic washer, but I'm going to apply that sealant with it anyway. And I found that 5/16 fits with this head, and I can also use this adapter for the impact drill. That'll make things a lot easier to drive these into the roof, and then I can tighten them up manually. So I have the solar panels up on top of the shed here, and next I have them aligned with one another, and I have the cables up at the top just sticking out. And now I'm going to mount both of these just in position by drilling the holes and putting in some of that sealant. Out here with the tools, we got the drill, we have the bit for the screws, and then we also have the caulking. So first I'm going to drill the full 4 holes on there. 4 holes drilled, and now I'm going to put some caulking in each of the holes, stuff it with the caulking. All right, I got the caulking down, and now I will put in screws and all of that. There's the screws squished down. You can see some of the caulking underneath, and just make sure it's nice and tight. Now I'll just go on the other corners and do all those. Now we have all the bolts in, and now I'm going to connect panel 1's male to panel 2's female, so they're in series. So panel 1 is connected to panel 2, panel 1's male is connected to panel 2's female, so we have panel 2's male, panel 1's female, and I'm going to connect the extension cable around the side. So I have the 10-foot extension cable, which is a little long to go around the gap, but I'll have to maybe swap it out for a shorter one. But I'll take the male and female, hook it up to the panels, and then I also just have this laying around that I might just put over some of this cable so it's not a red cable going over the side. So I have the cables tucked under the second panel. There's a little more gap under here, and I have it going into the plastic sheath running over the side. I have the wires coming off the side. I drilled a hole for the mount, and I'm going to feed these through and then connect these wires to the bottom of the gland and then tidy up this area. So I have the wires pushed in. I'm just going to use more of this on the back just to leave a seal around and then screw in the 4 screws. It didn't come with any screws, so I'm just going to use these 4 extra ones I have. Here it is mounted. I just put a rim of that caulking around the inside, then mounted it with the bolts. Just occurred to me that these bolts are zinc, so I might need to replace these with stainless steel, but it's mounted. And here it is tidied up. It would be nice to have a little more of this to do the whole thing, but it's good to have a drip loop and everything. Now inside, here's where I have the other side of the gland. This is a 10-foot cable, so it's 20 feet in total, which is just minor voltage drop, but we have the Sunmax here, have a Unify AP, so this is going to be the shelf where I'm going to put the batteries as well as hook up this Sunmax. So these 2 cables will hook directly into the Sunmax. So I finally have my 2 batteries fully charged, because it's good to charge them to full, especially since they're going to be in series. You want to have them basically linked. So I got the batteries up on the shelf, and then I just have a 2-gauge wire connecting them in series, and then I'll tighten these down. I have this convenient battery switch here where you can actually turn this to turn on and off the positive. So this is what I've had set up for now, and I'll go through what I have inside on this plywood. I've had the solar point set up for now, but I'm planning on expanding this. So let me go into what I have currently set up. So this is what I have for now set up on the board, and this is just so I can take it in and out off the shelf to make adjustments as what's needed. And I've been running the solar point off the positive and negative terminals here. So what I have is 2-gauge wire going straight to the batteries, and then this is going to 150 amp fuse because I'm going to be using the inverter and other accessories, including the solar point, and then just a negative bus bar. So next I'm going to attach the inverter here, and it's going to overlap a little bit and connect 2-gauge wires to another fuse and into this. Now we have the inverter set up, and you can see on the back I wired this 2-gauge up. You have the positive and the negative, and the positive comes through 125 amp fuse just for safety and goes to the positive bus bar, which then goes into 150 amp fuse to cover everything from the bus bar up to the battery. And then the negative comes right around here, goes to the negative bus bar, and goes up to the negative on the battery. So we're back out here. I got the inverter hooked up, and it's running. It tells you the input voltage and the output voltage, and I have it hooked up to this Ryobi charger, and we got electricity out here. I'm also really pumped because now I can run my air compressor without lugging it out of the shed. I can also run my saw out here because I was also lugging this around. So now that we have the AC power hooked up and usable, I'm going to hook up this blade fuse block where I can hook up 24 volt accessories around the shed. so I can hook up things like the LED lights. So I actually ended up putting up a platform in the middle of the shed, so I'm actually going to string up some lights over here with a motion sensor so that they'll come on and off automatically. And this is what comes in the box. You have the fuse block and just some labels, and usually you'll see these in cars or boats or things like that. And you wire up the red at the bottom for the positive and the positive for all of your fuses, and the negative at the top. It also comes with a variety of these fuses. So I put up a piece of plywood and I'm going to mount the fuse block on here just for easy access. And then I have the fuse block ready to be installed, and I'm going to use this 10 gauge wire that I had around, which will support up to 40 amps. But I'm probably only going to support one fuse block for now anyway, so I'll probably put a 5 amp fuse in there for the LED lights, and we will crimp some of the wire and get it ready to be mounted. So I went inside and made the cables, and we will connect this to the main bus bar, and then on the cover I'll probably end up putting like max 40 amps for the 10 gauge wire that I hooked up for now. Now I have it mounted up there, and I got the 5 amp fuse on this one, which I'll use for the LED lights. We'll hook up in a second, and we can put the cover right back on here. Alright, so I routed the wires around the back side here and just hooked up to the positive bus bar and the negative bus bar, and now we should have power on the fuse box over here. Okay, so I connected the motion sensor to the first fuse and just put it in some flex tubing over here, and then we can connect the lights to the other side of this motion sensor. All right, so the final piece of the solar project is in. It's not permanently done. I have some cabling that I just need to throw some heat shrink or covering on, or put it through a conduit here or whatever, but the lights are up and they're on this motion sensor like I was pointing out before. So we have the 5 amp fuse that comes down into the motion sensor, and then this provides the power to the start of this LED, and I have it on some quick disconnect, which goes over here to another quick disconnect just in case we need to change anything about them. Same thing on this side, and we'll have this lighting up the shed. So I have a few things planned that I want to put in here, something like an exhaust fan to make sure that the temperature stays at a good temperature for the batteries up here. And for now, we have the DC power running the lights, and then we have the AC power hooking up anything I want to hook up here, charging the batteries, things like that. So I'm really happy how this is coming along. I do have some cleanup I can do with the wiring that I'd like to get back to, with ordering some more heat shrink or something else to cover the wires. But for now, really happy with it as far as a shed goes. Before, I didn't really have any capability out here with electronics running anything, and now there's so many possibilities. So just to go over the cost of how this all broke down, I have it split up into 3 different sections: solar equipment, LED lights, and electronics. For the solar equipment, it ended up being roughly $363, and that's for the solar point. I got a good deal on 2 Renogy 100-watt panels for $100 from a third-party seller, some extension wire for the solar cables, the solar gland entry, which I mounted on the side of the shed to easily connect in and out the solar panels from inside the shed, and then the Renogy mounts themselves. For the LED lights, I sort of started from scratch since I ran out of equipment that I had available. I think the only thing I already had around was the 3-pin JST connectors, and then I got the motion sensor, the Cobb LED strips, the aluminum channels, and the 18 gauge wire, which ended up being around $70 for all that. For the electronics, it ended up being roughly $642, and that's the bus bars, the wire, the 2 batteries, the 2 fuse blocks, the battery disconnect switch, the crimping tool, the inverter, and the DC fuse block. Now keep in mind, I didn't purchase this all at the same time. I ended up purchasing it over a series of months and just slowly built up what I needed as I got further along the project. So in total, I ended up spending around $1,000 to get the solar set up in the shed. So if I wanted to run electrical to the shed, it probably would have cost a lot more, as well as had to go in the yard all the way around the house, add a new sub panel in the basement, and I didn't want to deal with any of that. I wanted it to just be self-sustaining, and I also wanted to try out some of this solar equipment and get a little bit into that. So far it's been working really, really well. I've been really happy with it so far, especially as we started getting into spring and I had this set up. I could run the saw, I could run the air compressor, I can hook up any of the batteries I needed to. So it's really looking great. I have the fuse block set up with the lights, so now when I enter the shed, the lights come on, which is really convenient. I'm hoping to add a few retractable things, like a retractable electrical outlet, so that I can easily pull that out and use my miter saw, and adding like a fan for the temperature because of the lithium ion batteries that I have. They have to stay within like 30°F to like 120°F. So I'm hoping to keep that temperature lower with a fan, as well as insulate the shed. Or expand on things like cameras. So with the Solar Point, that was sort of my original idea, was how can I have cameras around the shed to get a different view as opposed to the house. So hoping to expand on a few of those things. Now, reevaluating what I already did, I probably wouldn't start with the Solar Point again. Now knowing a little more about this whole solar ecosystem, I probably would have just bought a better MPPT charge controller that was more suited and more brand name. And then I probably would have powered a PoE switch off of that, and then had my access point running off that PoE switch. And the Solar Point isn't directly supportive of LiFePO4 or lithium ion batteries because of the charging temperature. So I think with the Solar Point, they can go down to 0°F and sort of accommodates a few different other temperature fluctuations of other batteries, but not quite the lithium batteries. So it's a slight risk that I'm using it, but I'm just assuming that it'll be fine with the temperature differences in the shed. And as opposed to using the Renogy mounts that I ended up using directly on the roof of the shed, I'd probably end up seeing if I could get some sort of multi-bracket panel holder where you can actually attach 2 to the bracket rather than using 8 of the mounts that I needed, as well as expanding. If I could add a few more panels, then that would also be helpful. One other drawback with the Solar Point as well is it can only charge up to 7 amps, which I totally understood going into it. Both of the panels that I do have, I think I could get up to like 8.5 amps. And so that is one drawback, is that I can only get up to 7 amps of charging. It's good enough for my needs because I'm just popping in and out of the shed, but otherwise I am losing out of that little bit of charging capability. So I hope this helps anybody looking to do a similar thing. I thought this was a great project and I was really excited to get into it, and happy that I could document it to share with anybody looking to do a similar project. Let me know if you have any questions, and thank you so much for watching.